What's up, guys? This is Coach Campbell, and today we're going to go through your assignment for September 23rd, 2020. Coach Campbell. Okay. So, what I'm going to do is just kind of go through maybe one or two questions from each little section, and I'll consider sections basically left side of the page, right side of the page. On your document that you've got online, it's just this is an entire page right here, and then this is an entire page right here, and then on the back we've got two more. Okay. So in my classes, my students suggested that I go through number two. I let them pick one problem from each section, right? So it says find the velocity of the line segment A. And here we've got our line segment A. Okay. I'm going to kind of color that in as blue. And then we've got line segment B, which I'm going to color in as red. Okay. So first, we're finding the velocity of line segment A on a position versus time graph. Position versus time. Okay. And in order to find the velocity on a position versus time graph, the only thing we need to do is find the slope. Okay. So the velocity is equal to the slope, which we know to be rise divided by run. Rise over run. You've heard that before in your math class, I hope. Okay, in this case, looking at line segment A, well, from this point on the left to this point on the right, looks like we rise 0, and it doesn't matter after that. If our rise is 0, our slope will be 0 automatically. So 0 meters per second. Okay, so there we have it. Remember, the slope is the velocity. On the red line, my pen's coming apart. There it goes. Okay, find the velocity of line segment B. Now we've got kind of a slanted line. Notice it's going down to the right. So I should already know that down to the right means it's going to be a negative slope, right? So my slope is rise over run still. In this case, I'll start here and in there. If we look, I'm starting at 60 and I'm dropping down to 10. Okay, so what's my rise? If I'm going from 60 to 10, that means my rise, first off, is negative because I'm going down, and I'm dropping down 50, so negative 50. Okay, negative 50 over, well, this is 10 seconds, this is 20 seconds. 0 seconds is there. I'm just following the graph underneath it. 10, that's 20. Okay, so from 10 to 20, I ran over 10. Negative 50 over 10 is negative 5 meters per second. Okay, cool. Good stuff. Now it wants us to graph these line segments on our velocity versus time graph, which is this one underneath. Okay, so I'll do that. Let's go ahead and have a look first at the section A. So section A, we said our velocity was 0 meters per second. Okay, and it held that 0 meters per second for 0 to 10 seconds. So for our first 10 seconds, we're simply going to put our horizontal line right there across. Okay. Section B, it drops to negative 5 meters per second at 10, right? So it starts becoming negative 5 meters per second. So right down here at negative 5, I'll make a horizontal line going across. And if you like to, we can connect the dots. Some of y'all like connect the dots. Doesn't matter. We can do that though. Okay, so there we have it. There's our velocity versus time graph that matches this position versus time graph. Remember, we found the slope of the position time to give us our velocity versus time. Slope here was 0, right there across at 0. Our slope here we found as negative 5. Okay, negative 5 right there. Okay, so that's the first page problem that I went through. On the second page, I once again asked them the same thing. Okay, they picked number 9. So we'll go through number 9, okay? But on this, just kind of like, I'm not going to write the answers down, but looking at this graph, we should be able to read on a position versus time graph, if we have a positive slope, what does that mean? That means we have a positive velocity going away from the origin, okay? Here we have a curve, that means we're having some form of acceleration. Looks like we're slowing down. We're not going quite as fast. This means fast. This means stopped. If we're going from fast to stopped, looks like we're slowing down right there. Okay. Stopped is a horizontal. And then what does that mean if we're having a negative slope, right? That means we're traveling in a negative velocity, okay, in a negative direction. We're traveling fast in a negative direction. Okay, I think that's all of those covered. Let's go on down to another question that I had. It says, what quantity can you find from these? Okay, well, right here, it's asking us for how far, that's displacement. How long does it take? That's time. What can we find from this graph given displacement over time? Okay, so I gave that one. It's going to be velocity. Using displacement and over time, position over time, we can find velocity. And then it wants us to calculate the velocity. How do we find the velocity given a position time graph? Well, we should find the slope. Okay, so go ahead and do that for that problem. Pause the video if you like. Catch up. I'm going to go through number 9. Number 9 says use 6 meters as your final position. Okay, so what that means is each of these lines, we're going to stop at 6 meters. There's 6 meters there, there, and there. Okay, so I circled all those spots. Those are going to be our final positions. Okay. Right. It says right there, circle where each line crosses 6 meters. So I technically did that. Okay. All right, so here we have our initial position of 1, and then our final position at each one is 6 meters. Number 9a says, using 6 meters as your final position, what is the change of x for each line? Change of x for each line. Remember that x is our position. Okay, so we're going from 1 to 6. What's the change from 1 to 6? Well, 6 minus 1 is 5 meters. And notice that they all stop at 6, and they all started at 1. So all of our answers should be 5 meters. Okay, here's where it changes up. How long does it take each line to reach 6 meters? We started at 0 seconds. We ended at 1 second for line A. So 0 to 1, that took 1 second. Line B, we started at 0 seconds, and we ended at 2 seconds, right? So we took 2 seconds. Line C, and then I'll let you do line D. We started at 0 seconds and we ended at 5 seconds. There it is. Now it says to calculate the velocity of each line. Remember that velocity is our displacement divided by time. So looking at that, we've got 5 over 1 for line A. 5 over 1 is 5 meters per second. That's our velocity. Line B, we had 5 over 2. Some of you like decimals, that'd be 2.5 meters per second. And line C, we have 5 over 5. What's 5 over 5? Okay, y'all fill in the rest. That's meters per second. That's calculating velocity. So notice, once more, just in a slightly different way, we calculated slope essentially. And the slope told us the velocity of each of these 4 lines. Cool. On to the backside. Great stuff. Okay, an object is going 50 meters to the left and later starts going 10 meters per second to the right. Find the change of velocity. I won't do this one for you, but I'll tell you that change in velocity is simply whatever your final velocity is minus whatever you started at. Okay, your final velocity minus initial velocity. Or I can help you to set it up. Our final velocity is what we ended at, and our initial velocity is what we started at, right? An object is going 50 meters per second. Well, if it's going that, is that our initial or our final? If you said initial, you're correct. Later, it is going 10 meters per second. Okay, so that means we finished at that velocity, VIVF. Now, substitute in your values and get your answer, all right? Let's look at number 3, sure. Okay, an object moves 3 meters away to 8 meters away. Find the displacement. Remember, displacement is a change in x. okay, which is x final minus x initial. It moves from 3 meters, that's x initial, to 8 meters away, that's x final. Final minus initial, that's 8 minus 3. What's 8 minus 3? 5 meters. Okay, 5 meters, that's our displacement. Moving on down. I'll go through two of these problems. Okay, this one and this one are quite similar. This one just looks like an upside down version of this one, doesn't it? Okay, so I'll go through this one right here and this one right here. Okay, it says complete each row to match the graphs of position, velocity, and acceleration. So we got position, velocity, and acceleration graphs. Now we're going to complete each row. Okay, looking at this first one, I'm going to color code them. I'm going to give us a blue graph. I'll give us a blue graph on this one as well while I'm at it. I'll give us a red graph in the middle. Hopefully you guys can see the different color. And then on the right, I will give a green graph. Okay. Green line, I should say. Hopefully y'all can tell the different colors. I think y'all can. Okay. Looking at that, now we want to change from a position versus time graph to a velocity versus time graph. So let's take this first section, this blue line right there, and we notice that it's a straight line. If you have a straight line on a position versus time graph, that means you have a constant velocity, okay? Remember, constant velocity is a straight line on a position time graph. Our constant velocity is going to be found by finding the slope. We said earlier, slope is rise over run. In this case, rise, we're going from here down 1, 2, 3, 4, 5, 6. Slope is -6, and then we went over 1, 2, 3. -6 over 3, that's -2 meters per second for the blue section. Now, our red section is curved. Well, we can't really find the slope of a curved line. What we can do instead is find the slope of this other straight line, section C. Looks like we've got a rise of 1, 2, 3. Over to the right, 1, 2, 3. 3 over 3, that's 1 meter per second. Okay. Now let's go ahead and graph those. So section A was -2 meters per second. So -1, -2 ends up being right there. -2 is right there. So we're going to graph that for the first 1, 2, 3 lines. Okay. And then we're going to have something for section B. We'll find out soon. And then we've got section C, which is at 1 meter per second. And that's for the last 3 lines. Okay. From there, we're going to connect the dots. Okay. So notice we went from a negative velocity going down to a positive velocity. So that's the same thing that happened here. Okay, it's accounting for that. So there we have our velocity over time graph. Okay, by section. So blue right here, -2. Then we connect the dots with the red to a slope of C, which is +1. All right, so there we have it. Let's go ahead and find acceleration now. Acceleration is simply the slope of a velocity time graph. Okay, so what's our slope of this first section? Our slope is 0, right? If our slope is 0 for the first section, I'm going to put the blue line just like that at 0 for 0 acceleration. This next section, our rise is up 1, 2, 3 over 1, 2, 3, 4. That's 3 over 4, and that's meters per second squared. Okay. Recall that 0 meters per second squared was this one, and green, if you look at green, it's also 0 meters per second squared because we have a flat horizontal line. All right, 3/4 of a meter per second. If 1 is right there, Then for 4 lines, I'm going 3/4 of the way up. Looks good right there. Between 0 and 1, we've got 3/4, right? And then what happens is we go back down, kind of making it look like a top hat. It flattens there out at 0 meters per second, okay, squared. So we're not accelerating. We're not accelerating here or here because our velocity is not changing here or here. It's only changing right here, okay? Excellent. Now let's look at this next one. Velocity versus time graph. It gives us A, B, and C on that. And now we're asked to find the acceleration first off. Okay, well that one should be simple. We just did that on the one above. Remember, acceleration is simply the slope of the velocity time graph. It looks like the slope of A is 0. The slope of B, well, B is also horizontal, right? So that's also 0. And then the slope of C remains 0. So it looks like our acceleration graph just goes right across there at the 0. Okay, let's see if I can zoom you in a little bit. Let's go ahead and finish up now with the position versus time graph right here. Okay, well, what is this telling us? What is this graph telling us? Velocity versus time graph. Well, remember that the velocity is the slope of the position versus time graph. So essentially, what we're being told is that section A, oh man, I'm gonna pause.
Juniors, please transition to your 8th period. Again, this is juniors, please transition to your 8th period.
Okay, I couldn't find the pause button, so we're just gonna keep going. Okay, we've got a slope of 2, so we've got 2 meters per second. Then our section B looks like it goes down to -1 meter per second. And then slope C is at 0 meters per second, right? So that means we're going to have a 0 slope over here. All right. Now, slope of A. A section should have a slope of 2 meters per second, 2, right? So I'm going to kind of start lower over here because it looks like we've got more of a positive change in position than negative. So if we start low, it should be able to be fine. I'll go ahead and start at the very bottom left corner. Okay, so 2, that means rise 2 over 1. I'm doing that for the first 1, 2, 3 sections. There's another, and there's my last one. Okay, my slope is 2. For every 1 I go over, I go up 2. For the red section, going down 1 over 1. So -1 means down 1 over 1, and it holds for 3 sections. 1, 2, 3. The last one that I've got is 0 slope. Hopefully we know that by now that a 0 slope is just a horizontal line. Try to color it in there. All right, I was able to pause it in time for that one. But yeah, guys, go ahead, complete this paper. Best of luck to you. If you've got trouble writing on these graphs on the Google document, I did send out a video where Mr. Peritano kind of explained, or we did send out a video where Mr. Peritano kind of explains how to draw on a Google Doc. Okay, so best of luck to you. We'll see you later. All right.